knowledge, options, and the tools to use them. This video will provide you all three. A power supply is an electronic device that takes AC current from your wall outlet and changes it to a DC current to power your electronic gear. In this video, I'm going to discuss the options that you have for different types of power supplies to run your shack equipment. I'll give you some things to think about and some other options to consider when looking for a power supply. I'm going to describe a decision-making tool that might help make things easier in your final choice. The first thing you need to do is determine how much amperage you're going to require. You do this by going to your owner's manual for the rig that you want to power up. Now, your owner's manual may list several different amperages. Always assume the worst case. This will usually be when you're transmitting using full power as opposed to just monitoring. This will give you a starting point for identifying how much power you'll need. You also need to figure out if you want to power up your entire shack with a single power supply or if you want individual power supplies for each rig. I prefer to have individual power supplies for each rig, but for your own reasons, cost, space, you may want to run your entire shack with a single rig. Now, if you want to run your entire shack, all you have to do is take all the worst case currents that you looked up in your owner's manuals and add them together. That'll give you the total amperage that you're going to require. Just FYI, 100 watt HF rigs pull about 22 amps, and UHF VHF mobile rigs generally average out at about 13. Of course, you'll want to do this for your actual rig. You can find information online on the manufacturer's website for your rig or in your owner's manual in the specifications page, which is usually almost the last page in your owner's manual. The next thing you want to do is determine if you want to go with a switching power supply or a linear power supply. Let's take a look at the block diagrams for both, starting with the linear power supply. As you can see, we start with a transformer. It's a very large transformer and it accounts for most of the weight in a linear power supply. Now, I did include a link to an online resource where I actually picked up these diagrams, but the guy there goes into a lot more detail on what is included in different types of power supplies. So you might want to go look at that link. Your home AC voltage enters the transformer on one side, and the other side is actually consists of a smaller number of coil wraps. Now that gives you a step down to your desired voltage. That voltage is run through a half-wave rectifier, which takes the sine wave and turns everything to a positive voltage. It is then run through a filter capacitor, which smooths out the half-wave rectified signal, and then runs it through a voltage regulator, which is going to straighten everything out. And finally, there's an output capacitor, which takes care of any residual noise, and you get a nice, clean DC output. There's a lot more to a modern linear power supply, as I mentioned above, such as overcurrent, overvoltage, and over-temperature protection. But this is a very high-level block diagram. Let's look at a switching power supply now. A switching power supply, well, they are different. It doesn't have a first stage transformer and goes directly into a bridge rectifier, which is going to change the input voltage into an unregulated DC. This voltage runs through a filter capacitor, which is going to provide some smoothing, and then goes into the regulator circuit, which outputs a chopped DC square wave. That current goes into a transformer where it is stepped down to the desired voltage and into a bridge rectifier along with several different feedback loops, which is going to give us a sawtooth wave. The output of the rectifier goes through a filter capacitor, which changes the sawtooth into a clean DC signal, and then finally there's a bleeder resistor. Again, there's a lot of circuitry that's not shown here. And for a more in-depth discussion, please see the link in the video description. Both types of power supplies have reputations. Some are deserved, some not so deserved, and maybe some are really badly deserved, but not anymore, maybe. Well, we'll chat about that in a moment. The linear power supply has been around for a long time. It's a proven technology. They're extremely reliable, very sturdy, and long-lasting. The switching power supply is a relative newcomer, or at least the use in ham shacks is relatively new. When they first came out, they were known to be noisy, poorly regulated, unreliable, and subject to catastrophic failures due to poor design and manufacturing flaws. Because of this, there are many hams who are hardcore linear power supply advocates. And let me stop here and say, good on them. You know, everybody has an opinion, and everybody's opinion is somewhat valid. In this case, it was. They will swear on the shacks that they will never use anything but. I used to be one of these guys. I even went as far as advising my ham radio classes never, ever, ever to even consider using it. But in the last few years, I've changed my tune. There have been advances in technology and manufacturing that make switching power supplies more resilient, safer, and certainly a lot better than the first generation offerings. Now, as a matter of fact, my shack is currently run by switching power supplies. Don't tell my hardcore friends. This is a decision that you'll have to make for your shack. Here's my opinion, that either a linear or a switching power supply is now a matter of personal choice, and there is very little functional difference between the two. The one caveat I make to this argument is that there are still cheaply made, low-quality switching power supplies on the market, and certainly on the aftermarket. Be a careful and responsible buyer, and you shouldn't have a problem. When you're doing your research, you'll find that the power supplies, both linear and switching, have two different power levels listed under their specifications. The first is the maximum power, and the second is continuous power. Now, the product part number will almost always indicate the maximum power. As a matter of fact, I can't think of a time when it doesn't. This is pure marketing. The real power that you want to look for is the continuous power. Maximum power is strictly temporary and to be used for short periods of time, measured in minutes, as opposed to the continuous power being the available power for, well, continuously. For example, I use Astron power supplies. The one that runs my HF rig is an SS50. So the average ham would think that this power supply would be good enough to run something that draws 50 amps, right? Well, fortunately for you, after watching this video, you won't be uneducated. The continuous current of this particular power supply is 40 amps. By the way, I have links in the video description to both the Astron SS50 and SS25 power supplies. Clicking on those links will take you to an Amazon page where you can purchase either of these. I do get a small commission for Amazon if you purchase using those links. It doesn't change the cost at all. It's just a finder's fee from Amazon to me. Also, I donate 10% of all monies made from Amazon to the Wounded Warrior Project. Now, as always, I support you shopping around. You can find these certainly not only on Amazon, but on Ham Radio Outlet and DX Engineering and other ham radio online sales sites. Really, I'm just trying to help you find your best deal and neither endorse nor discourage your choice of type of power supply or where you end up purchasing them. Comparing size and weight between linear and switching power supplies, you will find that the linear power supplies are considerably heavier and larger. I'm talking the difference between 5 pounds and 50 pounds. This is because of the large transformer that is in the linear power supplies. You'll also find a significant difference in cost, with the switching power supplies being much lower. You can save hundreds by going with a switching. That said, you may want to consider, because of its, you may still want to consider a linear power supply because of its proven longevity. Switching power supplies haven't been out there long enough to really tell. Are they going to last as long, or at least comparably? I had a 35 amp Astron linear power supply that served my shack for well over 25 years with absolutely no problems. As a matter of fact, I ended up selling it along with the radio that I was trading for at the time and replaced it with a 50 amp linear power supply. When I moved out of my new QTH, I outfitted it with the 50 amp and 25 amp switching power supplies. One that runs my HF radio and one that runs a VHF UHF mobile radio that I'm using in a base station configuration. As you're doing your research, you're going to find out that a lot of these power supplies have what I call bells and whistles. That is, they'll have meters, lights, many of them even have adjustable voltages and current. First off, I have no use for these kind of things for a couple of reasons. The adjustable power supplies, most of them are designed to be used in a lab. Certainly you can use them in a shack if you want to, but they can be dangerous. What happens if you accidentally bump a knob or change the voltage or current? The best case scenario is whatever you're powering up will simply shut down with no damage. I don't even want to think about what the worst case scenario might be. I'm sure you can come up with some. Now, as far as having meters on your power supplies, well, you're probably going to put your power supplies in kind of an out-of-the-way location, so you'll not really be able to see the meters. And that makes for an extra cost for something that you will probably never use. Now, we get down to actually making your choice. There are a few resources that you need to tap into to help finalize your decision. First, talk to the people in your club. I think it's a fair bet to say that just about everyone there will have a ham shack, and they're using power supplies to power them up. Find out what they're using. Get their opinion. Ask for their advice on what a good level for you would be, what a good manufacturer or type of power supply would be for your situation. You can also talk to your local ham friends if you don't have a club close by. It makes a great discussion on a local repeater. Don't ask me how I know. And you'll be bringing people out of the woodwork to give their advice. Now, though I'm hesitant to mention it, you can also use Facebook or some other social media platform. Take whatever you get, right? You know what happens on those things and the value of the information you're going to get. Mostly for the social media stuff, but really applicable to all of the examples, take everything with a grain of salt. Some people are very ingrained with their opinions, and some people haven't done the research that you're going to be doing. One last recommendation is to use a decision chart to help finalize your choice. Now, what I'm going to show you is a small part of a lesson that I taught to my graduate level logistics students. What I taught was much more in depth and is known as, in business classes at least, as a quality function deployment, or QFD.
This is your power supply decision chart. Across the top, I've listed 3 different power supplies that you're considering purchasing. The first is a linear, and it's called the MyPS-20A. The next 2 are switching power supplies. The first is a Zingong 15 amp and a BRCC 18 amp. Now, that's what you want to list across the top, and I've listed 3 here just for brevity. You could do it with 2, or you could do it with 20. Now, down the left-hand column here, you want to list your decision makers. Now, like the MyPS-20A, that 20A doesn't mean that you have 20 amps. You have something less than 20 amps. So that would be your continuous current, and that is what you'd want to put in this block here. Now you're also going to consider the cost. We're all on a budget. You've done some research and you found that the average median price for a power supply in this range is about say 140 to 160 bucks. Next are protections that it has. Now, I've picked these 3. You are not limited to 3, and you could do it with 2, but yeah, you're not limited to 3. You could continue on putting down things like how well regulated they are, what your friends have said about them, things like that. Recommendations and other specifications that are typical of power supplies. So now that we have those 2 filled, we're going to start filling out our things. We'll fill out the first power supply column first. This has a continuous current of 16 amps, cost of $155, and it has protections for current, voltage, and temperature. Not too shabby. Now you're going to give a rating between 0 and 5. Now, I picked 0 and 5. You can pick any rating scheme that you want. You just have to make sure that you are constant throughout. So, it's a 16 amp. In this first one, it's a 16 amp continuous. Your rig draws 13 amps. So you're plus 3 amps, so yeah, let's give it a 3. Not because you're plus 3, you're just a little bit over. 155 is right smack dab in the middle of where you thought the prices should be, and it's not an unreasonable price. And it's got protection for current, voltage, and temperature. That's pretty well protected. Give it a 5. The next one, the Zingong, the continuous current is 11 amps, which is less than the max current draw. However, you know that your base station your VHF, UHF base station can operate on lower power, and you could run 10 amps out, and that would be well below the 11 amp. But still, you give it a 1 because it's not there. Now, 89 bucks, that's a steal. What's up with that? That's a 5. You're way below the normal asking cost, and it does have current protection. It doesn't have full protection, but it does protect for current, so you give it a 2. The last one is 14 amp. That is above the 13 amp, but just a little bit, but it is above, so you give it a 3. Say it was giving you 20 amps, that would be a 5. Okay, but it's $210, way outside of what the cost should be, and it only has voltage protection, so you give that a 2. Now what you want to do is add up all your ratings and come up with the total numbers. You see that the MyPS has a 13, the Zingong has an 8, and the BRCC has a 6. At this point, you take the highest value, and that gives you your tells you what the decision chart has said. The final decision is still yours. You may decide to hop on that 89 bucks and go for it. You can do that. You may decide that you want that $210. You got money. You want to bump up your credit card. Well, good on you. So again, I picked 3 items and 3 ratings, and that's how you build a decision chart. I think at some point I'm going to do a full up QFD presentation, which has things like weights and many more columns and lines and charts and interactivities and stuff like that. But we'll consider that at a later date. For now, let's go back to the live Tom in the shack.
In the beginning of this video, I promised you that I would give you knowledge, options, and the tools to use them when buying a power supply. I hope I've accomplished that, and that you're walking away from this video with more knowledge, more options, and at least one tool to use them. Now, if you did get something from this video, whether that's new knowledge or new options, or if that decision tree was something that you may use when making a decision. Oh, by the way, it's not only for power supplies. It can be used for just about any decision. From what house you want to move to which car you want to buy, to what new HF rig you would want. But I digress. I wanted to ask you for your like. So please hit that thumbs up button. There it is, right there. Thumbs up button. Also, if these videos are something that you enjoy and help you develop as a ham, then please subscribe and ring that notification bell so you're notified anytime I post something new. 7-3 for now. I'm Tom, ND3N, and I'm out.